So I just got this Lightning Pro, Ford Lightning Pro charger, or it's just maybe called the 4 Pro charger. And this charger supposedly is the only charger available to do bi-directional DC control. I'm going to say charging, but this is just an EVSE, electric vehicle service equipment. That's EVSE. So let's take a look at this. Now there were 3 screws with a Torx screwdriver. So I used a Torx screwdriver, a T20 Torx. If you're not familiar with a Torx screwdriver, there it is. It's this type of screwdriver. And there were 3 screws. And I can remove the cover. Now I've already done one of these before in a previous video, and I wanted to go over the charger and what it can do. And I know there was an issue between what size wire to use and that how the Ford is requesting a number 3 wire, 100 amp number 3 wire, which we will use. But you can see here, this looks like very light gauge wire coming in. So this is my AC power in, toroidal coil to measure the current coming in. And this looks very, very skinny wire. It's got a really nice crimp, but this to me looks like at the most number 8 wire. Number 8 welding cable, railroad cable. So that's definitely not number 3. Let's go get a piece of number 3 cable to show you the difference. So here I have, this is number 2, this is number 4, this one number 4, and this one's number 6. And it's asking for number 3, which is in between these two, which I have. I'll wire this with the right wire, number 3. But I just wanted to show you the difference in sizes, if you can see that. And if we look at the terminals, our terminals here, A1, here's L1 and L2. This was this guy. Now, if we look at the difference between these cables and what Ford is giving, this is a number 6. This, to me, looks a number 8. This possibly could be number 6 welding cable. Anyway, I just wanted to show you guys the differences in wire sizes. These are all THHN wires. So I'm going to put. I can see various connections going in. I have 1, 2, 3, 4. So I have 4 low voltage wires. I have my ground, my line 1 and line 2. And then I have my inverter out, my DC output. You could see how skinny this line is. Now, I know how, so I want to see if this technology will work, number 1, with my E-Transit van, which I think it will. Now, they're saying it only work with the Lightning, but I want to test and see if I can actually get the DC, the 400 volt DC right from the car battery. I want to see if I can capture that on these terminals. And you can see. So the T15 will take off this cover. Okay, so it's uncovering a fuse. Okay, so we have a fuse here. So it's all the handwriting. So this is the 1L2, so that has to be one of these. Yep, there it is. And then this guy's got to be the other one, right? Okay. There's our ground. Now, we just have 2 more signals here. But there's 2 more wires that you don't see that's hidden in this push button. Inside here is the PP plug present signal. When you push down on this, as soon as you push down on this, this will open up and immediately cut power off. So this is always non-energized when this is free in your hand. The only time it's energized is when this PP, plug present signal, is in. So when this is in, you push this button, you push it in, it locks in, it lets it know it's in place. Where are those at? Yeah, this is the pilot control, it says. So these are the wires. 2 of these wires are going to be for the CP signal and the PP signal. So plug present, and then CP is the actual sine wave or square wave that this will tell how much power it's going to take out, right? So in other words, you can control the current from here. We can take the current, we can raise it or lower it from here. And what that does is just sends out a different signal. We'll check that out. Let's do that and see. So look, I got a USB port here. I'm really surprised that that fuse is non-serviceable and it's welded into place. I guess that's to keep it from bouncing around. It's got some potting here to keep it from coming around. This might be some sort of temperature sensor. Oh no, it's the current sensor. Okay. Yeah. Oh, we have 2 current sensors. So we have a current sensor here. I didn't even see that one. And then we have a current sensor here for both. So this is detecting any type of current flow. This is detecting just the current flow from L2. 208, 240 volt input, 80 amp, and it's 420 volt DC. And then the output, 80 amp, 420 volt DC. Well, this is like the cat's meow of chargers. Goes on top. And then this goes on the top. And this is the wall plate. So this will get mounted on the wall. Okay. So the only challenge so far is putting in these little screws. They're very hard to get in and reach. So there's a screw here and a screw here, and it's with the Torx screwdriver. This is the Torx screwdriver. So they're very little screws and they're hard to do. So what I've been doing is using a pair of needle nose, and I stick it in with the needle nose while I grab it with my Torx screwdriver. So what I'm going to do is connect it to my 1450p. And if you guys have subscribed to the channel, you know that I ran 3-wire already to all my locations. So I've got 100 amp feed here on a 50 amp breaker. So I've got number 6 ground, and then a number 6 neutral, and then 2 number 3s hots. So what I'll do is I'm going to double it up, and so I can use this and this because I'm going to be doing testing. So we'll see. So this is the breaker, it's off. You know, one thing I want to say is, you know, don't do any electric work that you're not qualified to do, okay? So people have leaving me comments that I'm irresponsible, and guys, I've been doing this for a long time, so I'm very confident I'm licensed to do this. So if you're not, you can just take it with a grain of salt, but this is something you can easily do yourself, easily. Okay, see you in a little bit. Okay, stand by for test. We're gonna test the standard wall connector that comes with the Ford Pro with the CCS charging, and we're gonna be doing full tests. So I already was disappointed with one test. I did plug this into my E-Transit and I did not see the DC power. I did not see the DC power from my E-Transit. It should be 400 volts. So a couple tricks I'm going to do with the home integration system for this. I really don't need that integration system. I already have all my equipment. I want to be able to use this Ford Pro to take my E-Transit batteries. So I want energy storage to the bi-directional charger to my equipment, to my inverter. I don't need the Sunruns equipment. I have my own. So I'm going to find out. And then if I can get it to work on this, I want it to get it to work on my Tesla. And then once I find out, then I'll offer it to you guys. All right, subscribe. Please like this video. I never ask anybody to like anything. But if you like these videos and you're interested in what we're doing with Manny and Mo and all my solar, my off-grid solar, battery storage, and now working with this Ford Pro, please like and subscribe, guys. See you later.